Hello students, in today's video we are going to learn about electromagnetic radiation. So let's start. In the mid-19th century, physicists were studying the thermal radiations absorbed and emitted by heated objects. So what were they studying? They were studying about thermal radiations. Now, thermal radiations is made up of two words, thermal and radiations. What does thermal mean? Thermal means anything which is related to heat. Relating to heat. And radiations means, in physics, it is the emission or transmission of energy in the form of waves or particles through space or through a material medium. So basically, it is the emission or transmission of energy. Okay. Now, this thermal radiations, what were these thermal radiations made up of? Scientists, physicists wanted to know about that. So the first active study related to this was done by James Clerk Maxwell. James Clerk Maxwell. He was a Scottish physicist. He was a Scottish scientist. So this was the man who in the year 1865 published a dynamical theory of the electromagnetic field. And in this theory, Maxwell demonstrated that electric and magnetic fields travel through space as waves, moving at the speed of light. So electrical and magnetic fields, they travel in space and they move with the speed of light. He proposed that light is an undulation in the same medium that is the cause of electric and magnetic phenomena. So, basically what did he say in his theory? He said that electromagnetic field is produced when a charged particle is accelerated. Then what happens when a charged particle is accelerated, or if the charged particle undergoes acceleration, then that particle will produce what does it produce? It produces alternating electric and magnetic fields. In the form of waves. So he suggested in this theory of electromagnetic theory suggested that when a charged particle is accelerated, it produces alternating electric and magnetic field in the form of waves. And this theory was later on confirmed experimentally by Heinrich Hertz. So this was the man who confirmed the theory by experiment. Now let us try to understand this theory with the help of this diagram. You can see that In this diagram, there is an electric field component, magnetic field component, and direction of propagation. So whenever a charged particle is accelerated, this charged particle will produce electric field component and magnetic field component, and this fields will be produced in the form of waves, and these waves will get propagated along a particular direction, which will be the direction of the electromagnetic radiation. So this, if this is a z-axis, then these waves oscillating about the z-axis vertically, okay, up and down, this is the electric field component, electric waves, and the one along the y-axis is the magnetic field component. So this electric field component and magnetic field component are mutually perpendicular to each other and perpendicular to the direction of propagation of the waves, okay, or the radiation. So this is what he called as electromagnetic radiation, or in simple words you can call it electromagnetic wave. Okay. Now this electromagnetic radiation has got different characteristics. The first characteristics I've already discussed about, that the electric field component, magnetic field component mutually perpendicular to each other and to the direction of propagation of the wave. And the second one is they do not require any medium to propagate. Unlike the sound waves or the water waves, sound waves require medium to travel, water waves require medium to travel, but this electromagnetic radiation can travel in vacuum as well. Okay, so, and there are different kinds of electromagnetic radiations depending on the frequencies and wavelengths. So they differ in their frequencies and they differ in their wavelength. If we talk about light, light is also an electromagnetic radiation which was revealed again by Maxwell, because before this, during the earlier Newton times, Newton had proposed that light is made up of particles which he called corpuscles. But later on, Maxwell showed that light also consists of alternating electric and magnetic fields, so he considered this as an electromagnetic radiation. So the wave nature of light was established, which was able to explain many phenomena like diffraction and interference. So the electromagnetic radiations, there are different kinds of electromagnetic radiations which differ in their wavelength and their frequencies. Now let's understand this with the help of this diagram. Now this is the spectrum of electromagnetic radiation. Now what is the spectrum of electromagnetic radiation? It means that different kind of electromagnetic radiations which vary in their frequencies and their wavelength. Frequency is represented by the Greek letter nu and its unit is hertz, and wavelength by lambda, unit is meter. So there are different kinds of electromagnetic radiations make up the spectrum of electromagnetic radiation. Like different colors of the visible light make up the spectrum of the visible light, visible spectrum, starting from violet, indigo, blue, etc. Webber, okay. So this is the visible spectrum. So similarly, this is the electromagnetic spectrum, and point to be noted is that the visible spectrum is a part of this electromagnetic spectrum, because light is a part, or it is an electromagnetic radiation. Now you can see that there are different kinds of radiations, are radio waves, microwaves, infrared waves. This is the visible spectrum, visible light, UV, ultraviolet, X-ray, and gamma rays. So from radio waves to gamma rays, the frequency is increasing, and from radio waves to gamma rays, the lambda decreases, okay, because both are inversely proportional to each other. One will increase and the other will decrease. Now these electromagnetic waves, all this kind of electromagnetic waves, they travel in vacuum with the speed of light, which is 3 into 10 to the power speed of light is equal to 3 into 10 to the power 8 meter per second. Now talking about the frequency, what is the frequency? Frequency and what is wavelength? Now if I draw a wave, okay, now the length of this complete wave, this length, okay, this length is going to give you the wavelength. This is represented as lambda, okay. Now this is another wavelength, okay. So for a wave propagating, the wavelength will always remain the same, okay. So this is lambda, or in alternate ways you can also find wavelength as to be the distance between two high points or two low points. High points are crests and low points are troughs. So the distance between these two high points, crests, can also be called as lambda, and this to this distance can also be called as lambda. Now this is wavelength, and what is frequency? Suppose there is a fixed point and this wave is continuously propagating along a particular direction. Then the number of waves, complete waves which cross a fixed point in 1 second is called as the frequency. So the unit of frequency will be second inverse or hertz. Okay, because number is not going to have any unit. So number of waves per second is going to give you the frequency. So now let us consider a random electromagnetic wave which has got a frequency of say n waves per second. So I can write the frequency, means if n waves are crossing the fixed point in 1 second, then the frequency becomes n per second, okay. Now, we know that if it is an electromagnetic wave, it has to travel with the speed of light, okay. So, and we also know that speed is given by the relationship distance covered by time taken. Now, in 1 second, n number of waves crosses the fixed point, and if one wave has got a wavelength to be lambda, then the length of n such waves will be n into lambda. So this n into lambda is the distance covered and time taken is 1 second. Now you see, n per second is what? It is the frequency, isn't it? So instead of n per second, I can write frequency, and frequency is represented as nu, okay. So I can write this as, now speed can be written as c, implies that c is equal to frequency, which is nu, into lambda. So here comes the formula, the very famous formula, speed of electromagnetic radiation, which is the speed of light, is equal to the frequency multiplied with lambda. So this way, if we know the value of lambda, we can calculate the frequency, and if we know the value of frequency, we can calculate the value of lambda, because the value of the speed of the electromagnetic radiation is always fixed and is equal to 3 into 10 to the power 8 meter per second. So this were the important information about electromagnetic radiation, about the frequencies, wavelengths of electromagnetic radiations, and about the visible spectrum, the light. Talking about the visible spectrum, the light, it has got the range of wavelength from 400 to 750 nanometer, and violet has got the least wavelength, and red has got the maximum wavelength of 750 nanometer. So I hope that this video was helpful to you. If you learned from this video, please do like the video. Please subscribe to my channel if you haven't. Please share my videos, and please do not forget to press the bell icon. I'll come with more interesting and more useful videos. Thank you, dear students.